Hello friends, Mr. Burrell here. We're just about to start a new unit here, Unit 6. We're talking about exponents. All the different kinds of things we can do with exponents, what exponents are, how we work with them, how we can deal with different and simplify different exponential expressions, etc., etc., etc. So this unit is going to be all about working with exponents. So we're going to start right here in the first lesson. We're going to talk about exponent rules. So there's a few different rules we follow when we're working with like simplifying exponential expressions. And today we're going to start by talking with the product and the quotient rule. And I'll talk about what those mean in this lesson. So by the end of this lesson today, these are the things that I hope you're able to do. I want you to be able to use the product rule in simplifying exponential statements and the quotient rule in exponential statements. Seems intuitive. That's what the title of this lesson is, yeah? So by the end of this lesson, you'll be able to use those two rules to simplify exponential statements. So just as a preface, when we're talking about these different kinds of expressions, I wanted to show you kind of where in the real world we see exponential expressions used, where people use exponents. In computers, computer games, a lot in marketing, calculating like interest on a loan or on an investment or something like that. Population increase, like estimating how fast a population grows, exponential growth in debt, so like how fast you accumulate debt, bacteria exponential growth, lots of things that either grow or decay. Exponential decay is something that sometimes you talk about like in a chemistry class. Those are some of the places where we see exponential expressions used in the real world, which is why we discuss in this unit how we work with them, how we simplify them, and the kinds of things that we do with them. So, just as a review, an exponent, or a power, if I wrote something like this, 3 with this little 5 up here, I'd read that as 3 to the 5th power, where 3 is the base and 5 is the exponent, right? You've seen stuff written this way. This isn't terribly new information. An exponent just determines how many times I multiply the base by itself. So like 3 to the 5th power, or 3 to the power of 5, is just a fancy way of writing 3 multiplied by itself 5 times. 1, 2, 3, 4, 5. 3 times 3 times 3 times 3 times 3, that's 3 to the 5th. It's just 3 multiplied by itself 5 times. Okay, so there's a section in your guided notes that typically I'd have you do with a partner or in a group that I'm just going to do with you. So, for example, if I have 2 times 2 times 2 times 2, that's equal to 2 to the 4th. Okay, because it's 2 multiplied by itself 4 times. And if I actually like computed that, 2 to the 4th power, that's 16. 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay? Same right here, 2 times 2 times 2 is just 2 multiplied by itself 3 times. So 2 to the 3rd power, 2 times 2 is 4, 2 times 2 is 8. So 2 to the 3rd power is 8. Great, that's awesome. Well, what if I wrote in each of these expressions, 2 to the 4th, 2 to the 3rd, if I wrote them out here as 2 times 2 times 2 times 2 times 2 times 2 times 2. How many are there? How many times am I multiplying 2 by itself? Well, there's 1, 2, 3, 4, an extra 3 here, so 5, 6, 7. I could write this as 2 to the 7th power. Because there's 7 of them. I'm multiplying 2 by itself 7 times, so I could write it as 2 to the 7th power. That's the exponent form. And if I actually determine what that is in my calculator, 2 to the power of 7 is 128. Okay. So, what about this one? What if I have 2 times 2 times 2 times 2 over 2 times 2 times 2? Well, first of all, if I wrote that as 16 over 8, because 2 to the 4th power is 16, 2 to the 3rd power is 18. If I wrote that as 16 over 8, I bet you could do that pretty quickly. 16 divided by 8 is equal to 2. Well, notice when I'm multiplying all these things together, notice that 2 divided by 2, that cancels out. 2 divided by 2, that cancels out. 2 divided by 2, that cancels out. And I'm left with just 2. Yeah? So if I write it out, instead of just 16 divided by 8, if I write it out in its prime factors like that, 2 times 2 times 2 times 2 over 2 times 2 times 2, 3 of the factors in the bottom cancel out with 3 of the factors in the top, and I'm left with just 2. Or I could write that as 2 to the first power, since there's only one of them, however you would want to write that. So we're going to use this. We're going to use this to answer some different kinds of problems. So in the next section of your guided notes, instead of numbers, I have some letters. So like for example here, I have x to the 7th times x to the 5th. So that's x to the 7th is 1, 2, 3, 4, 5, 6, 7 x's multiplied together. And then x to the 5th is another 5 x's multiplied together. So this is 8, 9, 10, 11, 12. So there are 12 x's being multiplied together. So I'd write that as x to the 12th. Notice here, if I didn't write this all out, notice what happened here. Notice the relationship here. I had x to the 7th times x to the 5th, 7 x's, plus an extra 5 x's that I'm multiplying together. That's a total of 12 x's that I'm multiplying together. So I write it as x to the 12th. I added these two exponents together to give me 12 total x's that I was multiplying together. Okay? What about these ones? If I had like x to the 7th over x to the 5th, well, again, kind of like I did with the 2's, I have 7 x's on the top, 5 x's on the bottom that are all being multiplied together. These x's cancel, these x's cancel, these x's, and these x's cancel. I'm left with 2 x's on the top and nothing on the bottom. So 2 x's on the top multiplied together would be x squared, right? 5 in the top and in the bottom canceled out, and I'm left with just 2 being multiplied together in the top. Again, notice the relationship between the exponents here and my final answer, what that exponent is. I had 7 x's in the top, 5 x's in the bottom. I subtract 5 of the x's from the bottom from the 7 x's on the top. 7 minus 5 gives me 2 x's left on the top. Okay? Okay, that's cool. That's great. Oh, let me draw that line again so you can see the arrow. What about this one? X to the 5th over x to the 7th. So take a look here. I have 5 x's on the top, 7 x's on the bottom. Well, these x's cancel, these x's cancel, these x's cancel, these x's cancel, these x's cancel. So in this case, all the x's in the top cancel out, and I'm left with only 2 x's on the bottom. So on the bottom of the fraction, I have x squared. In the top, if everything cancels out, I'm just going to have 1. So that would be 1 over x squared. Note the difference between these two problems. Here I had more x's on the bottom than I did on the top, so I took my 7 x's on the bottom, subtracted the 5 x's on the top, and I was left with 2 x's that are being multiplied in the bottom. Over here I had 7 x's in the top, 5 x's in the bottom. 5 of the ones on the top canceled with 5 of the ones on the bottom, which left me with 2 x's on the top. So, as a general rule, on all of these problems, technically you can write out all the x's, count how many there are, or see how many of them cancel out. As a general rule, something we start to notice with these exponents is that when I multiply exponents with the same base, like x to the 5th times x to the 7th, like I just had, when I multiply exponents that have the same base, like this x, I add the exponents up. I add the exponents together. So I add the exponents. So for example, x to the 5th times x to the 7th is x to the 12th, because I'm multiplying 5 x's plus an extra 7 x's, which is a total of 12 x's that are being multiplied together. So when I multiply exponents with the same base, I add the exponents. When I divide exponents with the same base, so like x to the 7th over x to the 5th, or x to the 5th over x to the 7th, when I divide exponents with the same base, I subtract the exponents. So you notice when I had 7 x's in the top and 5 x's in the bottom, 5 of the x's in the bottom canceled with the 5 of the x's in the top. So 7 x's in the top minus 5 x's in the bottom just gave me a total of 2 x's that were left in the top. Over here, when I had 7 x's in the bottom, 5 x's in the top, 7 minus 5, that left me with 2 x's in the bottom. Okay? So as a general rule, those are the rules I follow with multiplying and dividing exponents. Okay? So, what if I have multiple variables with exponents and numbers and lots of stuff going on? Well, the same principle is going to apply. Check this out. So, 3a to the fourth b to the fourth times 4a to the third b to the third. Well, I could also write that as 3 times a times a times a times a, 4 times b times b times b times b, 4 times 4 times a times a times a, 3 times b times b times b, 3 times. Okay. So if I write it out that way, well, 3 times 4, I can multiply those together right off the bat. 3 times 4 is 12. And as far as a's go, I have 1, 2, 3, 4, 5, 6, 7 a's that I'm multiplying together, so I can write that as a to the 7th. And I have 1, 2, 3, 4, 5, 6, 7 b's that I'm multiplying together, so I can write that as b to the 7th. So my final answer here would be 12a to the 7th times b to the 7th. And notice, without even writing all these out, you can kind of notice here, if I have 4a's here, 3a's here, that's going to give me a total of 7a's being multiplied together. 4b's here, 3b's here, that's a total of 7b's multiplied together. Okay, so I'm counting up all the numbers of those specific letters that I'm multiplying together. Okay, what about 4x to the third y to the third over 2x squared y squared? Well, that's really 4 times x times x times x times y times y times y. And on the bottom I have 2 times x times x times y times y. Well, I can see right here that a pair of x's are going to cancel out, a pair of y's are going to cancel out, and 4 divided by 2, can that be simplified at all? 4 over 2, well, if I divide both of those by 2, 4 over 2 is just 2. 4 over 2 is 2. And then I'm left in the top with an x and a y. An x and a y. So my final answer here would be 2xy. Because I had 3 x's and 3 y's on the top, 2 x's and 2 y's in the bottom. 2 of the x's in the top canceled out with 2 of the x's in the bottom. Same with the y's, which left me an x and a y on the top. So 2xy. Let me do another example real quick. Let me do something like this. Throw in a z. So what if I have 6x to the 5th times y times z over 2 times x squared times y cubed? Well, let me erase this. This answer is 2xy. Give myself some room. So I could write 6 times x times x times x times x times x times y times z all over 2 times x times x times y times y times y. Okay. Well, look here. I have a pair of x's that can cancel out. A y that can cancel out. Right? And then 6 divided by 2, that simplifies to just 3. And that leaves me with 1, 2, 3 x's on the top, which I can write as x to the third, times, there's just still a z up on the top. And then in the bottom, what do I have left? Well, the 6 and the 2 canceled to make 3. I have 1, 2 y's, so on the bottom I have y squared. So my final answer here would be 3x cubed times z divided by y squared. And you notice here, again, I had 5 x's on the top, 2 on the bottom, which left me with just 3 on the top. See that? Whoops, 3 on the top from my 5. And then if I have y on the top, y to the third on the bottom, I have 1 y on the top, 3 y's on the bottom. That leaves me with 2 y's on the bottom. And then I have this 1 z that just is chilling there. So that's it. I have some challenge questions here. If you want to challenge yourself with some of these, feel free to pause the video here and try out some of these kind of more intense, I would say, exponential problems. Well, hopefully by the end of this lesson, now you're able to use the product rule in simplifying exponential statements, use the quotient rule in simplifying exponential statements, and be able to simplify a variety of different exponential statements with numbers and with different variables. So I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever. And I hope that you enjoyed that as much as I did.